All right, here's a nice ice table question or equilibrium question. So they give you this reaction. I wrote it down here and I balanced it. It's all 1 to 1 to 1 to 1, which is nice. And then they say initially these are the concentrations, and then the NO2, that's this one, at equilibrium was this, and so they want me to find the constant of equilibrium. Okay, so my constant of equilibrium is going to be equal to the concentration of N2O times the concentration of O2 divided by the concentration of NO2 times the concentration of NO. And these have to be at equilibrium. So one of those I know. I know this one here would be 0.118. But I need to know what those other three numbers will be. And I can use my ice table to find that. So I take a look at what happened from here to there. So they told me initially, and then this one is at equilibrium. So I figure out what happened. So on my calculator I'm going 0.118 minus 0.0560 equals 0.062. That's the change. 0.062. And it was added to that. So if it's on the same side of the equal sign, or of the equilibrium sign, then this one also has to be added by 0.062. I should have had a 0 in front of that. Now on the other side of the equation, so both of these went up by that amount. On the other side of the equal sign, they would have to have gone down. So they have to go down by 0.062. And this one down by 0.062. Okay, so I'm going to take 0.294 minus 0.062, 0.232, and that's NO, and that goes right there. So that number, 0.232, goes right here. And then 0.184 minus 0.062, 0.122, and lastly 0.377 minus 0.062, 315, 0.315. So N2O is right here, 0.122, and at equilibrium oxygen is at 0.315. So now I take those on my calculator. Again, on your calculator, go 0.122 times 0.315, divide, and then in brackets go 0.118 times 0.232. You can put brackets around the first two as well, but it doesn't make any difference. But if you don't put brackets around the second ones, it will make a difference. So 0.122 times 0.315 divide bracket 0.118 times 0.232 bracket go. So it'll be the constant of equilibrium will be 1.40378, etc. Looks like 3 sig figs everywhere, so I'd probably write it as 1.40. So that'll be my equilibrium constant. Okay, hopefully that helps you. Now being 1.40, it's interesting because typically we say if it's 1 or above, or if it's above 1, it favors the products. If it's less than 1, it favors the reactants. But in this question, it shows a little different because